In the last lecture, we found out about slew rate in operational amplifiers, and that the slew rate is typically determined by the compensation capacitor chosen and the amount of current that you desire to burn. In this lesson, we're going to start talking about stability. Op amps are almost always used in a negative feedback configuration, and the reasons we do this are numerous. The pros of using feedback are, one, that feedback sets our bias point for us. So we don't need to use large coupling capacitors in our circuits. Or at least we can reduce the number of coupling capacitors we use. We've already seen that feedback increases bandwidth. When we reduce the gain of the op amp, we get the gain bandwidth remains constant, so our bandwidth increases. Because of our gain being reduced, we can also have a larger linear output range. In feedback configurations, our gain is determined solely by the feedback. And these are typically ratios of components. So our systems are less susceptible to component variation, or process voltage and temperature variation, which I'll call PVT variation. The cons are, one, feedback loops can become unstable. Here we'll just make a note, if the feedback isn't negative. At all frequencies. What we're going to find is that we need to be careful about the phase shifts around our loop. And the second con is that we have to compensate to ensure stability. All right. Let's look at the macro level here for our non-inverting amplifier. We know that we can draw our non-inverting amplifier as the following configuration. And that we can represent this as a control system where we have an operational amplifier with a gain of A of S, and we have a feedback circuit that's subtracted from the input signal to create an error voltage that is fed into that amplifier. We derived the gain for this system with respect to S. A of S is equal to little a of S divided by 1 plus A of S times beta. And sometimes we label the term A of S times beta as our loop gain. So we could also write this as A of S divided by 1 plus T of S, where T of S is our loop gain. So A of S is our closed loop gain. Little a of S is our open loop gain. And T of S is our loop gain. In the next part of the lesson, we'll learn how the system can become unstable.